closed interval. So whenever you see less than equals to, greater than equals to, all this one, so it is a closed interval. So if I exclude the word equals to from the greater than equals to, so it's an open interval. Okay, so this is a closed interval. Is either I write it in this form or I write it in this form. So if I write my a comma b in this form, it is a closed interval. And if I like, I can write it in this form. Okay, let me just put x here. It is also a closed interval. But if I remove this nonsense away, it becomes an open interval. Don't stress about that. Okay, that's it. So suppose f of x and g of x are two functions. So what is said to be an orthogonality? So on a closed interval, an orthogonality function is said to be this, like integral of a to b f of x dot product of g of x dx when it's equals to 0. That's what we call our orthogonality. But when we are asked to find our norms comes with, for instance, I said find the norms of x. So you represent your norm of x as this. I put this two stroke. So this is what we call norms. Okay, just the way you said, okay, absolute value of x. You know, if you are talking about absolute value of x, you just have just a stroke, then x a stroke. So, but when you double it, it becomes a norms. Good. So now, a norm of f of x is the inside the bracket integral of a to b, then your f of x, all carrying square dx, then everything carrying half. But most cases, when you are talking about the Lagrange leading to De Morgan's, there's a rule we called I'm trying to remember, but anyway, we'll come back to that. It was that kind of rule leading to we use it under vector and tensor analysis anyway. So most cases they will not put this raised to power half, they'll just put square root. But knowing fully well that whenever you see square root of a function or any identity, it is still the same thing as carrying power of half. Okay, no stress. Alright, so let's continue further by defining orthogonal set of a function and orthonorm set of a function. So I will now do just an example and give a class of which you are going to drop your answer to me in the comment section. So let's go. Alright, I'm going to be filling this. I'm still talking about, so this definition 1.3, okay, so please jot it down if you don't want to fail. Good. So let's set fn of x, then n equals to 1, 2, 3 be set of function defined on some interval a to b, now. So then the set, fn of x is set to be an orthogonal set of a function on the interval a to b. All right, so this defines orthogonal set of a function, no stress. Now orthogonal set of a function is integral of a to b m subscript n f subscript m of x, then f subscript n of x dx equals to 0 whenever m is not equals to n. Now definition 1.4. Alright, so these definitions, they really matter, so it is left for you if you read it. If you don't read it, we'll graduate in TN. Alright, so orthonormal set of functions. Okay, so let your set fn of x such that n equals to 1, 2, 3 ... regarding depends on what you have in anyways. That will be the set of function defined on some interval. Oh my god, there's a mistake here. Defined on some interval a to b, then the set, the fucking vibe of function defined on some of these interval. Oh Jesus. A to b is said to be orthonormal if they are orthogonal on the interval a to b. Alright, so on the interval a to b. So I want you guys to see it whether that's why I'm writing it. Alright, and all have the norm to be 1. Thus the set f subscript n of x is orthonormal on a interval a to b if and only if, or you may not write this if and only in full. You can just abbreviate it in so that you have IFF. Okay, so integral of a to b f subscript m of x f of fn of x dx equals to what? This. So these ones are defined, these functions are defined this, and you have it like this. So just look at it, write it and jot it. So I'll just solve just one question. I'll solve just one. So Then after solving that just one question, I will drop videographer. First of all, question so I will solve one question. I'm sorry, I'm hungry, no verse, just one question. So I want them to gain. I'll solve one question, then I will now drop. I'll give you an example will be displayed on the screen. Then you're going to solve it and drop your answer in the comment section. Anybody that gets it without the use of AI, trust me, I'm going to give you 5k each. Anywhere you're watching from, any university you're watching from, please don't use AI. Use your head. You understand? So that's it. All right, let's move to the question. I think I have a question here. So if you are not getting this definition right, I suggest that you kind of just backward it and save it. All right, we have an example here. Example 1.0. Show that the set of functions 1, cos x cos 2x, dot 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 is orthogonal in the interval. This is a closed interval, okay? So we want to show that this is so. I think this should not be a problem, all right? So case 1, solution. Case 1. So if you want to show that this is what? This is orthogonal. You know the definition of orthogonal. So we can be like, let's use case 1. Alright, let's find naught of x equals to 1 and find of, you have L, M, N. So but we don't need this. So let's just use this. So let's find of M be what? M of x equals to, let's just pick one of these. So we're picking this one. Let me do this side. So find M of x is equals to cos x. So let's use that one. So now we want to show if this is orthogonal. You know orthogonal. So that would be what? You are going to apply the dot product. That would be find naught of x dot phi subscript M of x is equals to the integral of a to b, now. The integral of a to b such that phi M of x so phi N of x dx equals to 0. So this is what we are solving for, okay? So we have what's our a? Our a on this interval, our a is, this is a and this is b. Okay, so that's minus phi to phi. So what do we have? What do we have as this one? This is 1 times, what do we have as this? We have what? Cos x. This is cos what? Cos mx. As regarding this one, so we're having cos mx. So the x, that's it, no stress. So at this junction, you can just be like, you integrate this one. So when you multiply this one together, you're having integral of minus phi to pi, then cos mx dx. So when you integrate cos mx, you are having what? You are having sine. If you integrate cos, you are going to be having sine. That is sine mx over m. Okay, so sine mx over m, then minus phi to phi. No stress. So at this junction, if you now apply the normal way we solve integration, so that will be sine m pi over m minus sine m minus pi over what? M. So you know how it goes. So it's subtract. So anytime you have, note that when you have sine nx, for instance, whenever you have sine nx, it's automatically equals to 0. When you have cos nx, is minus 1 raised to power n. So minus 1 raised to power n is constant. So master this. So I might decide to put n, I should not put m, and I can decide to put any constant there. Alright, so at the end of the day, this and this one is equals to is 0, because is 0 divided by m minus 0 divided by m. At the end of the day, you're having 0. So you can see at the end of the day, solving for this one, it is giving us equals to 0. So it satisfies that what? It is orthogonal. Okay, so alternatively, if you don't want to go with this, maybe you want to go with, let's pick the other one. Alright, so okay. Alright, let me do like this. Anyway, I was thinking I should use another question, but let me still use this one. So case 2. Don't let me use one. Initially I used this one and this one, so don't let me use this one this time around. Case 2. So let's phi of mx equals to what? Cos mx, okay? And phi of nx equals to cos nx. Because they're having n here, that's why it's cos nx, alright? So n can be 1, 2, 3, and the same thing repeated to for m. So now we want to solve for this. We want to check if it is orthogonal, alright? So this is what we do. You dot it inside, then you have the integral of what? Minus pi to pi. So what do we have for phi m of x? Phi of m of x, we have cos mx, alright? Times cos what? This one is cos nx, then dx. Everything carrying what? Dx, alright? So no stress. So now this one we cannot integrate it unless we express it to the identity of trigonometry. So using the identity of trigonometry, this one is we are going to be using the product to sum, okay? The product to sum rule. Now look at here clearly. Look at here very well. The product to sum rule. We are having cos this and this. So we'll be using this one. So it is a like look. It is a look like, sorry. So we are going to be applying this one to this so that we can express this one in this format, so it can be easy for us to solve the problem. So look at this now. So it looks like, so applying the trigonometry identity. So this one is going to be giving us integral of minus pi to pi. So we are having 1 over, at the end of the 1 over 2 into cos, let this one to be your a, according to this, let this one to be your a and this one to be your b. So that will be cos into bracket mx plus nx, okay, plus cos into bracket mx minus nx. So we have applied trigonometry like that, so no stress. Alright, so we'll bring this constant outside because we are integrating 1 over 2, then minus pi to pi, okay? So we are now having cos, this, what's common here, x, cos into bracket m plus n, then x comes out, plus cos into bracket m minus n, then x comes out, right? So we're having our dx, so this one is still going. Alright, so if you are going to solve this one, if you integrate this one, you are going to be like 1 over 2, then open a large bracket, integral of minus pi to pi, then cos into bracket m plus n x dx. We are expanding the integration, then integral of minus pi to pi, cos of m minus n x dx. No stress. This is the only question I'm going to solve, then I'll give you a class talk. I just want you to be flowing with me, so study those identities, very important. Alright, so at this junction now you can see I'm trying to make things easier here. So anyway, so at this side we have equals to 1 over 2, the big bracket. So when you integrate this one, so it's going to be giving you, at the end of the day, should be giving you sine into bracket m plus n x over m plus n. That's it. Then plus, when you integrate this one, you are going to be having sine into bracket m minus n x over m minus n. Okay, so at the end of the day, you put this interval here, you have minus pi and pi. A math student, you should know this. Alright, so we are having what? Half into bracket what? So now I've told you earlier on before now that when you're having sine constant of x is always 0, regardless of whatever multiple of anything that you have. So please master them. So sign of any nonsense that is there is 0, except if it is constant, then you'll be having minus 1 raised to power n. It is constant there. So that one is going to be applicable when you are treating your Fourier trigonometrical series. So that one is going to be the third videos I'm going to drop, but not today. Alright, so this is saying is 0 divided by n plus n, then plus is 0 divided by n minus n. Okay, so alright, no, we have not substituted, sorry, we don't need to rush. So we input this one now, that will be sine n plus n phi over n plus n plus sine into bracket n minus n pi over n minus n minus, if you now substitute it, you're having what? Sine m plus n. This one will be plus because minus times, you understand now? Okay, this one, okay, it is correct. So m plus n, then minus sine, okay, minus, okay, plus sine n minus n pi over n minus n, then you close the case. So this and this can be added. We have 1 over 2. This one and this one are alike, so that's 2 sine into bracket n plus n pi over n plus n, then plus 2 sine into bracket n minus n pi over n minus n. So by the time you collect like times, you understand what I'm doing there. So that's it. So 2 is common here, so these 2 can come out. So you're having 2 over 2, okay, sine into bracket n plus n over n plus n plus what? Sine n minus n pi. So don't forget this pi, you are still there, over n minus n. Alright, so don't forget, so this one automatically is 0. So any other you're having sign of anything pi or anything x, it is 0 according to the rule. So this one is gone like this. So we're having left sine into bracket n plus n pi over n plus n plus sine into bracket n minus n pi over n minus n. Alright, so no stress. So automatically this is 0 divided by what? N plus n plus what is 0 divided by n minus n. So automatically saying that it is 0. So it is very clear that at the end of the day, the results we got for the orthogonality of this is giving us 0. So since we are able to show we are able to show that these two functions, after solving it, is giving us 0. So we therefore say that it is what? It is the orthogonal set of a function. So if it's not giving it 0, it is not orthogonal. It's not going by it. It is not satisfying the rule. It is not satisfying the condition. So I love you guys. So make sure that you watch over and over again if this video is not clear to you. And if you find it helpful, drop a comment in the comment section. Please don't pass it. We are spending a lot of money and we are spending energy for you guys just to pass. So now I'm going to be dropping, anyway, you see on this screen below, I'm going to be, I might use a voice note and I can just tag it here, so you will see it there. So I'll drop the assignment. So I love you guys. Don't forget to subscribe to my channel. I am your one and only Eli Tutor. Yeah, come, look, this is mathematician. You are going to explain this one to us. Yeah, explain to us.
Don't post it to a